All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing some research on a couple of different things. And if we have some time remaining, because unfortunately I did start the stream, I mean, we still have some time. We have like a good hour and a half, maybe hour and 45 minutes. We would have had a little more time if I would have started the stream half an hour early, but then let's just say some stuff came up, so I wasn't able to get to it. But I mean, we still have some time. I've been doing research. I've been doing research. There was actually one thing that I was supposed to be um, asking Gemini about, but I cannot remember exactly what it was. Unfortunately, give me a second here. Okay, so uh, what are we doing today? So, dude, okay, this is interesting. I wanna tell you guys about this. Um, yesterday, I was doing some research on a bunch of different things, including whether or not somebody could learn electronics from scratch, and I mean both analog and digital electronics from scratch using microcontrollers, because we are living in the digital age, right? We are living in the age of microcontrollers. We have been living in the age of microcontrollers for the past like decade. Um, Microcontrollers are incredibly common, be it something that's incredibly beginner friendly like Arduino Uno, or something that's cheap and affordable yet packed with tons of functionality like ESP32, right? We have microcontrollers available a lot more than they were before, and they're being used a lot more than they were before. These days, you see kids are being taught about robotics, and they're being taught how to use microcontrollers and stuff. So after seeing all that, I started wondering, because like, okay, here's my thing, right? I used to be big into electronics as a kid. Back when I was a kid, and this was I'm talking about like a good um, 2.5 decades ago. Okay, a good like 25 years ago or something. From a very early age, I was big into electronics. I would love to take things apart, be it toys or home appliances or whatever. I would love to take things apart and just see what's inside. But also, I would love to take their various components and then connect them together and see the thing working. Even if it was something as silly as taking taking one or two LEDs and taking a DC motor from like from like a um, an RC car, and then connecting all of them together in series using batteries. Even if it was something as simple as that, that was still exciting to me, because like it was still something, it was something new for me. I didn't even really understand what I was doing. I just knew that it excited me, so I kept on doing that. And then a couple years later, I actually did proper research on it once I grew up, and I understand, or once I grew a little older than that age, and I started doing proper research. I learned about electronics. I learned about very basic electronics related calculations, how to apply Ohm's law in various situations, and it was still very basic stuff. I never really went too advanced with analog electronics, but it was enough to set up very basic circuits, and that was great. I did that for a while. Fast forward a couple years later, my family gifted me my very first microcontroller. It was an Arduino Uno, and that's what sort of began my journey with microcontrollers and digital electronics. And a couple of years after that, I discovered ESP32s, And seeing how cheap they were and how packed with features they were, I was like, dude, holy shit, I need to order a bunch of these. And so I did that, and since then I've been using ESP32s only. And the thing is, I never got a chance to go. I wouldn't even say like intermediate. I was still very much a beginner in analog electronics. Setting up complex circuits was just out of the question for me. A lot of the very basic calculations that I knew, they would work for simple circuits. But when you have circuits that are like branching out in different directions and you have components that are connected in different ways and stuff like that, the calculation becomes a little more sophisticated, a little more complex. And I just never really got too deep into that side, mostly because a bunch of the stuff that I wanted to do, it was getting handled by, what do you call it? By microcontrollers, because like a bunch of the stuff had become digital already at that point. So I did try to learn. It's not that I didn't try to learn. It's just that I realized that given my concentration issues and how much I tend to like jump from one topic to another, I'm just not able to stick to that commitment of reading a bunch of um, information that's only analog related. Like I tried that. There's this amazing website called I think it's called All About Circuits. I think so. Yeah, go check out All About Circuits. They have like they have like massive amounts of information. They have like a properly created tutorial section for like a whole syllabus. They have a whole syllabus for various electrical engineering topics, and they start with analog, and you do analog for like a good while before you ever even touch digital. So that's like a gold mine if you're looking to learn electrical engineering. That is a gold mine. That's a free resource. You can access the information on the website for free. It's amazing, right? I tried that, and I noticed that I'm not able to remain with that. It's like a lot of information, which is great, but I'm just not able to stick with it. So I needed another way. Just reading stuff, just doing stuff on paper, it is not really working out for me. So I was wondering, since I am very much interested in microcontrollers and I do use microcontrollers, let's assume that I don't know anything about electronics. Okay? Going with the assumption that I don't know anything about electronics, would it be possible for me to learn about analog and digital electronics through microcontrollers? This is the important part, specifically through microcontrollers. And I had a conversation with Gemini about this. I actually want to show you guys the conversation that I had. Give me a second. Can I open up? Okay, I'm gonna have to open up Gemini here, and then load up that checkpoint, and then save the uh, save the conversation so I can show it to you guys. Like, oh, by the way, I was curious if there were Rust based Markdown viewers, because so far I've been using well, okay, more specifically Rust based TUI Markdown viewers, because so far I've been using Frogmouth, which is a Python-based Markdown viewer. It uses textual for doing the TUI rendering and stuff. And because I've been working within the Rust ecosystem a lot more, so I was curious what tools are available. There are a couple, and after checking out a couple of them, one that I really liked was MDTUI. And that is this one. It's pretty fast, let me say that. Like this is the wait, what's going on here? What's up with that? Okay, let's clear that. Um, yeah, this is the application. This is how fast the application is. Something I need to look into is text wrapping in code blocks, because if you look at uh, which one should I show? This one up here. Wait, let it go back up there. Man, I'm trying to show how fast this tool is, and then SSH kind of cocks me by creating lag. Okay, I can do it here on another machine. Okay, so something I need to look into is this. If you notice here, it mentions in the output. The output is kind of like it's cut off there, so it's essentially truncated. I need to see if there's a way to wrap it. But other than that, I'm loving this Markdown viewer so far. At least for this specific purpose, yeah, it's great. I can download a test Markdown file to actually test what the actual viewing capabilities are with this. Because there's a bunch of different Markdown features um, that need to be handled. Something I was curious to test is trying to make a Markdown viewer myself. I don't know. I'll see. Maybe I can look into that later, because there's a lot of like there's going to be a lot of parsing related tech involved. So I'm going to have to do a ton of research for that. And to be honest, given that I already have a bunch of projects lined up, I don't know if I want to really, spend the time with that extra project. Oh, okay. The thing is loaded on the other machine. I actually wasn't really even planning on exporting this. I just saved the checkpoint. Um, what was it called? I can't remember. Not share. First, I have to resume. Learning analog electronics with microcontrollers. That is the one. So we resume this, and then we share. Gemini explains um, learning analog electronics with MCUs. .md. This is a long file name, but I don't give a shit because I'm going to be deleting the file as soon as I'm done reading it out. Now I can quit this chat. Yeah. Now, learning. There's another thing that I was doing research on, by the way. So there's this thing. Holy shit! For some reason, it was hard to say that. There's this thing called Ventoy that I came across. I actually came across this maybe a month or two back through TikTok. Someone else was mentioning it in uh, in one of their tech related videos. They had mentioned Ventoy, and I had looked into it, and then I kind of got distracted with other stuff. And then yesterday, I was watching a video, and somebody had, or well, the person that was stitching the original video brought up Ventoy, and then I looked into it, and I was really surprised because here's the thing, right? Okay, so um, in the past, when I wanted to make a bootable USB of let's say Ubuntu, let's say I had Ubuntu, and wait, hold on, yeah, let's say I had Ubuntu, the Ubuntu OS, and I wanted to make a bootable USB out of that so that I can plug that into any desktop and or even laptop and just boot up the OS through the USB. If I wanted to do that, I would either have to use the startup disk creator on Linux or Rufus on Windows. Like these were two prominent applications for a while for making bootable USBs. And because I do the majority of my stuff on Linux, so I haven't touched Rufus in a while. I was using Startup Disk Creator. Now, here's the thing, right? That worked for only one OS. So you could you could essentially burn that OS onto, and they're explaining that same thing here because I'd asked a question. But yeah, this worked for burning, quote unquote, burning one OS onto um, a USB a USB flash drive, so you could then plug it into any PC, and it would the OS would be booted up from that flash drive. But after reading up on Ventoy, I learned that apparently after you have set up Ventoy on a flash drive, I still have to like get proper information on it. I haven't like done all of my research on Ventoy, but so far what I've understood is that you can install Ventoy on your flash drive, and after that you all you need to do is copy ISOs, or there are other types of files as well, but all you need to do is copy ISOs of those different like distributions, those different OSs onto the flash drive. You don't need to go through some complex setup process, or you don't need to like reformat the flash drive, which is what you would need to do with the startup disk creator. You don't need to do any of that. And that's crazy to me. Like that makes creating bootable USBs so much easier. I could I could create I could download like a bunch of different um, OS ISOs and just put them onto a Ventoy flash drive. I have like a one of my flash drives is like 64 GB because like they're super cheap these days. They don't cost too much, right? So one of my flash drives is 64 GB. So I could easily put a couple of ISOs on there. And apparently the way that Ventoy works is if you have a couple of ISOs on there, then when you plug it in and boot it up, when you boot up from the USB, then Ventoy is going to go through all of those ISOs and present you with a menu, so you can choose which ISO you want to boot into. And that's crazy to me, dude. That like holy shit, that saves so much time. That is insane to me. That saves so much time. That opens up so many different possibilities. Like this is the difference here is between needing one USB and just putting a bunch of ISOs on there versus needing a bunch of USBs and having to spend the time in Startup Disk Creator formatting the USB and then putting the OS on there and making it a bootable USB and all that. Like this is a major difference between these two. So I was really interested in learning about Ventoy more, and so I asked this question. Let me go to the top. Um, okay, so here's what my prompt was. Just don't mind the way that the sentences are like structured and all. It's just how I was trying to get Gemini to give me as much information possible, as much information as possible. Okay, so I said, hey, so I'm used to creating bootable USBs for Ubuntu using Startup Disk Creator. That, as you know, creates a bootable USB for one instance of Ubuntu. But I've recently learned about something called Ventoy. Apparently, you can put multiple ISOs into it, and it can make bootable what? And it can make them bootable for you. How does that work? And if that was possible, why were we using this very limited process with programs like Startup Disk Creator on Linux and Rufus on Windows? Also, I remember there used to be this issue where after you've made a USB, a bootable USB, you can't normally format it after that because of some kind of partition table issue. I've never understood what that was all about. I did to a certain extent understand, um, because like essentially you're supposed to make this USB capable of interacting with the file system, but when you're turning it into a bootable USB, then it kind of gets rid of that, and so you have to then bring that functionality back into the USB through something like gparted, for example. Um, you have to write a partition table to it so that the OS can recognize it. But it's still like a very messy process, and I didn't fully understand exactly what was going on there. So I did want more information on it. But yeah, continuing. I never understood what that was all about, but is that also what? But is that also Oh, but is that also an issue? Hold on, what? Why did I write it like this? But is that also an issue the same with Ventoi? I think maybe I was trying to ask, but is it also the same issue with Ventoi? I'm trying to understand all about this Ventoi thing because it seems super useful. Okay, so then Gemini did a bunch of Google searches. First, it mentioned this. It said, got it. It's smart to dig into how Ventoi works. It's a very useful and powerful tool compared to the traditional bootable USB creators. I'll explain the key differences and answer your questions. Okay, so it did a bunch of Google searches here, and then it came up with this answer. Um, Excellent. I've gathered all the necessary information now, and I've gathered all the necessary information. Now I can provide a complete answer addressing each of your questions. Here's a breakdown of how Ventoi works and how it compares to the older methods. How Ventoi works, the smart boot manager. You've got the main idea right. Ventoi is fundamentally different from tools like Startup Disk Creator or Rufus. Think of it this way: traditional tools like Rufus, these tools unpack an ISO file and turn your entire USB drive into a dedicated installer for that one operating system. They're essentially burning, quote unquote, the ISO to the USB, much like you would burn a CD. Damn, dude. I remember burning CDs back in the day. Holy shit. That was crazy. CDs and DVDs and um, for a brief period of time for movies, we had something called VCDs. I think yeah, they were called VCDs before DVDs became, cheaper and much more widely used. Anyways, the USB drive becomes the installation media. Ventoi, um, wait, something is off here. Just a second. Just a second. Something is off with the way this is being rendered. Just a minute. Give me a second. Yes, you know what? Something is still off with the rendering here. So we are, for the sake of not making things confusing, we're going to open this up with Frogmouth instead, where we have, hopefully the rendering is handled much better here. Okay, so we looked into traditional tools, and then we have just a second. I need to look into something because I'm curious about why it opened up in that way. So I do have MTD installed on the other machine as well. MTD, MDT, MD, MDT. Yes, okay. Um, this is, yeah. This is a bit of a, this is a slight rendering bug with MDT, which I guess I can report. Anyways, we can carry on here. Um, where was I? Yeah. So, traditional tools. These tools unpack ISOs. We got done reading that. The USB drive becomes the installation media. Man, I was excited to check out the Rust-based equivalent of a Markdown viewer, but it turns out Frogmouth is a lot more feature complete. Let's say. So I guess MDT is still in like its early stages. Let me look up how long Frogmouth has been in development. Just a second. Also, yeah, okay, we're good. Okay, Frogmouth, a markdown browser for your terminal. I forgot why I was opening this up, but it does seem like Frogmouth is a lot more. It has a much better reception than some of the other tools. So I guess in the Rust ecosystem, specifically for TUI, I should mention that as well because what I'm looking for, it's not just a Markdown viewer. It would have been a little more simpler if it was just about a Markdown viewer. This is about a TUI based Markdown viewer. I need it to be a TUI based Markdown viewer because I use the terminal like a lot. Um, but yeah, I guess in this case we are gonna stick with Frogmouth, which is kind of why I'm glad that I installed, what was it called? PipX. Yes, I'm glad that I installed PipX um, because there are select few tools that are Python based that PipX helps with. Okay, anyways, let's carry on with. Wait, I was supposed to send this file over, right? Okay, so we want to copy Gemini explains learning so and so to um, okay uh, right scratch stuff empty directory. Okay, all right, that's copied over and we should have the file now. So if I close this, I should be able to open the thing up using. I should be able to open the thing up using Frogmouth. Yeah, here it is. Though there was some stuff that I was there was some stuff I was supposed to delete from it before doing that, but that's fine. Okay, all right. I gave like this whole entire like this is a massive prompt that I gave to Gemini. I guess I'll read it out later on. Once we do get into that, then also in the meantime, I'm not sure what information is there. So, um, give me a second while I set something up here. Oh, you know what? It's not all that much. It's not a big deal. Yeah, it's not a very big deal. Okay, all right. Um, so frog, frogmouth? No, Ventoy. So Ventoy. Let's continue reading about this. Okay, Ventoy doesn't unpack anything. Instead, it installs a tiny smart boot manager on your USB drive. When you boot from the USB, the Ventoy program starts up first. It then scans the rest of the drive, finds all the ISO files you've copied, and presents you with a menu listing them. When you choose an ISO, Ventoy loads it into the computer's memory and boots it directly. When you first set up a USB with Ventoy, it creates two partitions. A small hidden partition that contains the Ventoy boot manager itself. This is the VToy EFI partition. And then there's a large partition formatted as exFAT that takes up the rest of the space. This is the partition that shows up on your computer, and you can simply drag and drop your ISO files into it like a regular flash drive. Why wasn't this always the method? The traditional method was the standard for so long because it's a simpler, more direct process. It mimics how bootable CDs and DVDs worked. The computer's BIOS slash UEFI firmware was designed to look for a specific bootloader file and start an operating system. And the easiest way to provide that was to dedicate the entire drive to a single OS structure. The technology behind Ventoy is more complex. It requires a bootloader that is intelligent enough to act as a mini program that can run before any OS, be able to read a standard file system, scan for and parse different types of ISO files on the fly, and trick the computer into thinking it's booting from a real CD slash DVD drive when it's actually just reading a file from the USB stick. This level of sophistication is a relatively recent innovation in bootloader technology, which is why tools like Ventoy have only become more popular in the last few years. The partition and formatting problem. You are spot on with this issue with older tools, and you've hit on the biggest advantages of Ventoy. When a traditional tool like Rufus creates a bootable Ubuntu drive, it often writes a custom partition table like MBR or GPT and uses file systems that are specific to the Linux boot process. Your operating system's standard formatting tool, like the one you get when you right click and format, sometimes get confused by this non-standard layout and doesn't know how to properly erase it. It might only see one small partition and fail to wipe the entire drive, leaving it in a weird state. To fix this, you have to use a more powerful low-level disk management tool, um, such as DiskPart on Windows or gparted or DD on Linux, to completely wipe the drive's partition table and start fresh. Ventoy solves this problem because the main visible partition is just a standard data partition. Your computer can always read and write to it without any issue. You can add ISOs, delete them, and add other personal files right alongside them. If you want to stop using Ventor, you can simply delete the ISOs and use it as a normal flash drive. If you want to remove Ventor completely and recover that tiny bit of space from the hidden partition, you would still use a tool like DiskPart, but for day-to-day use, it's not a problem at all. Okay, right. So that's the. Oh wait, no, we're not almost. We're not done reading the thing completely. We're almost there, but um, just a second here. just doing something here. Actually, you know what? Give me a second. Let me hydrate because I've been talking for a while. Oh, okay. So, um, right. In short, Vento is a more advanced and flexible tool that solves many of the limitations and annoyances of the older single ISO methods. I am curious about something, so I kind of want an answer from Gemini about um, this. So give me a second here. Let me see how quickly Gemini opens up. Um, I think it was explains Ventoy. Oh, I don't think I saved. I don't think I saved a checkpoint for that. Yeah, I don't think it's. I don't think words. I don't think I saved a checkpoint for that. Which that's fine. I can quit this and go back here because I'm curious about this bit that it mentioned about how the tech behind Ventoy is more complex, and how it also mentioned that this level of sophistication is a relatively recent innovation in bootloader technology, which is why tools like Ventoy have only become popular in the last few years. I am really curious about this. Give me a second. I'm going to open this up elsewhere. NeoVim, Gemini explains Ventoy. Um, right. Okay, so let's yank this and then close and open up Gemini. I was about to say Gemini because I've been saying Ventoy the whole time. Okay, so that opened up. In another conversation that me and you were having, you mentioned the following. Okay, I guess just a second because yanking the thing apparently didn't copy it. So, okay, scratch stuff, empty directory, um, NeoVim, Gemini explains Ventoy. Okay, so the technology behind so and so and so and so. Okay, does that help? Right. I have no idea what's going on. Um, okay, whatever. In another conversation about Ventoy, and why it's more common now than it was previously, you mentioned the following. Can you explain this a bit more? I haven't really understood how things have um, changed between back then versus now that enabled something like Ventoy to be developed. I'm probably going to end up replacing this file. So real quick, let me just exit from there and then, uh, right, now we can just, of course, let's break down the evolution of bootloader technology that paved the way for tools like Ventoy. I'll create a new file. Ventoy explains bootloaders to explain it. That's interesting. Okay. All right. Hold on. I didn't ask Gemini to create that for me, but Gemini created it. Let's open it up. Bootloaders. I'm curious about this. I'm curious as to what made you. Wait. Okay. I'm glad that you thought about um, writing the info to a file instead of dropping it here in our uh, Convo terminal window. But I'm curious as to what made you guess that I would want to do that, even though I never actually told you to do that. You're right, you didn't explicitly ask me to write it to a file. My decision was based on a few factors: content length and complexity. The explanation was quite detailed, involving multiple sections and a table. Um, Pasting such a large amount of text directly into the chat can be overwhelming and harder to digest or refer back to. That is true. I've noticed that the Gemini CLI is not able to render tables very well. Or it could just be that it's not able to render tables very well in my specific instance. Like maybe I'm a little too zoomed into um, the window. How do I say that? Maybe I'm a little too zoomed in for stuff to be rendered properly, and um, Gemini would be rendering, or Gemini CLI would be rendering things a little more better if I was zoomed out. But I cannot be zoomed out because then I can't read. That's a possibility. Okay, referenceability. A file provides a persistent artifact that you can easily open, reread, and so on. So, okay, organization. For detailed explanations, a structured file allows for better formatting, which improves readability and so on. Contextual awareness. In a developer environment, it's common practice to store detailed detailed explanations or generated content in files. Anticipating that it might be needed for the future reference or something. Okay. You know what I'm wondering? I'm wondering if it's the fact that I actually, okay, I also just realized that you guys cannot see any of what I'm doing here, because I'm not doing it on a machine that is, wait, just a second. Why are we having bad frames? Is there something open in the browser that's eating up? Hold on, let me just close a bunch of stuff that might be open. It doesn't look like there's stuff that would be taking up that much. Okay, we can close a bunch of things anyways. Let's close this and close that and that. We don't need to close one specific one, but we can close this, and we can close this, and there seems to be like a YouTube thing running for some reason, but I think that's from a Google thing. Okay, all right. Once all of these close, then we should be doing a little bit better. But yeah, okay. What was I saying? I don't remember. I don't remember what I was saying, but I think it might be because I pasted Markdown into Gemini CLI. Maybe that's why Gemini CLI thought about doing it in this way. This is a good amount of information, which I could read right now, or we could move on to, because I'm still curious about this and I'm going to read it, definitely. But I'm, but I also want to show you guys that. Um, Actually, you know what? Yeah, let's do that. So we'll open this up in Frogmouth. Give me a second here. Okay. So this was my prompt. Okay, I'm gonna read out the entire thing. Um, I was really trying to give as much detail as I could to Gemini. So I gave like a like a backstory kind of thing, and basically what I explained at the beginning of the stream, that when I was a kid, I was into electronics, and um, as I grew up, I learned like basics of electronics, like still very basic calculations and stuff. I didn't really go too deep into it, and then years later, I got into microcontrollers. Years after that, I got into ESP32 microcontrollers. And then now I'm wondering if learning. Actually, I don't think I need to read out this entire prompt, because this is pretty much what I explained at the beginning of the stream. I might as well give you the answer that Gemini gave. Um, The answer was, of course, it's a fantastic question that gets to the heart of how electronics is taught and learned today. The short answer is absolutely yes. In fact, for many people, learning electronics through microcontrollers is a more engaging and effective way to learn both digital and analog concepts that the traditional theory first than not that. Okay. In fact, for many people, learning electronics through microcontrollers is a more engaging and effective way to learn both digital and analog concepts than the traditional theory first approach. I feel like this sentence is very important to understand because I feel like that's the case with me and a lot of other people as well. But like, I feel like this is the case with me, and this is probably one of the reasons why that whole theory thing of, reading a bunch of text first and then at some point later going into breadboards and what do you call them, multimeters and stuff. Maybe that's why this approach hasn't really maybe that's why that approach hasn't really worked for me. Um, but yeah, I'm super tempted to try this out. I'm like really, really tempted to try it out and create a syllabus because something that I want to do. It's not like I'm super interested in analog electronics and I want to go like really deep into analog electronics, but I do want to learn like the basics. I want to learn, not okay. I know the basics. I want to learn. I want to start from the basics though, because I'm gonna start this. When I do set up the prompt to get Gemini to teach me, what I'm gonna do is I'm gonna tell Gemini to assume that I don't know anything about electronics. Okay, I know nothing about electronics, so we're gonna start from there, and then we're gonna go into simple analog electronics concepts and stuff. And throughout this entire time, we are going to be using microcontrollers to study analog electronics. Let me show you something that actually a couple of things that Gemini told me that made me a little more confident about this idea that we would be able to learn analog electronics through microcontrollers. Some of these things occurred to me, but not all of these things occurred to me. Gemini said this. Here's a breakdown of why and how it works. Microcontrollers are a bridge, not an island. A microcontroller is a digital brain, but it lives in and interacts with the analog world. This forces you to learn analog electronics to get anything interesting done. Sensing the world, which is analog in, to read a temperature sensor, a light sensor, or a potentiometer, you need to understand analog signals. The microcontroller's ADC, which is the analog to digital converter, is the tool you use, and it directly exposes you to concepts like voltage levels, voltage dividers, and signal noise. You'll quickly learn why you need a capacitor to smooth out a noisy signal from a sensor because you can see the erratic readings in your code. Then controlling the world, which is analog out. So this is how you're sending signals out from the microcontroller to control things. To dim an LED, control a motor's speed, or generate a sound, you'll use pulse width modulation. While PWM is a digital technique, the result is an analog effect. That's probably where a digital to analog converter is used, right? I believe so. I believe so. Pulse width module. Yeah, yeah. I believe that's where a DAC is used. Um, this naturally leads you to learn about filters, like using capacitors and inductors to turn that digital pulsing into a smooth analog voltage. Then, theory follows practice, which is more motivating. The traditional way of learning is bottom up. Learn Ohm's law, then Kirchhoff's law, then spend, or is that Kirchhoff? I'm going to say Kirchhoff. I don't know. Kirchhoff's law, then spend weeks solving abstract circuits on paper before you ever make an LED blink. This is what I'm talking about. Think about this. Really think about this. There's a whole lot of theory that you go into, which might have worked like in the past. For past generations, that might have worked, and um, a, this might have been a way of learning. I don't know if I would say this was the best way of learning, but at the time, this is what people were able to um, how what am I trying to say? At the time, this is the best that they were able to come up with. I don't want to say best, but like this is what people were able to come up with, given the tools that were available to them. Fine, great. The microcontroller approach is top down. So your goal, I want to build a plant watering system. The problem, my soil moisture sensors reading is unstable. The solution, you Googled it and find you need to add a bypass capacitor to stabilize the voltage. The learning, now you're motivated to learn what a capacitor is and how it works. The practical need drives you to understand the theory. You're not learning about capacitors in a vacuum. You're learning about them because they solve a real problem you're facing right now. Then, okay, this is where it gets interesting about using a microcontroller as a sort of multimeter slash oscilloscope slash logic analyzer. You don't need an expensive oscilloscope or multimeter right away. An Arduino or ESP32 can be programmed to be a basic version of these tools. Voltmeter. Use the ADC to measure voltage at different points in your circuit. This is a perfect way to verify your calculations for something like a voltage divider. You can calculate what it should be, then measure then measure it with a microcontroller to see if you were right. This is how you'd learn to verify Ohm's law and Kirchhoff's law in in a practical way. Then simple oscilloscope. You can have the microcontroller read the analog pin thousands of times a second and send the data to your computer to plot. This lets you see this lets you see how a capacitor charges and discharges or visualize the noise on a power line. Then logic analyzer. You can program it to read digital signals and see how components are talking to each other. Summary. Can you learn it all this way? Basic components, yes. You'll use them constantly as switches, pull ups, pull downs, filters, and amplifiers for sensors and actuators. Calculations, yes. The need to calculate the right resistor to protect the LED or the right capacitor for a timer circuit will force you to learn and apply the math. Solve then solving circuits, Kirchhoff's law. Yes, in a practical sense. You can build a circuit, apply the laws on paper to predict the outcome, and then use your microcontroller as a tool to measure the real voltages and currents to confirm your understanding. So to the core of your So, to your core question, for a complete beginner in this day and age, starting with microcontrollers is arguably one of the best ways to be introduced to the entire field of electronics. It provides context, motivation, and a hands-on lab environment, um, all in one tiny, inexpensive package. You learn the digital side by coding, and you learn the analog side because you have to make your code interact with the real world. Okay, I just got a follow. Tic Tac Whack. Thank you for the follow. Welcome to the stream. Hello, hello. We are currently doing some research on a couple of things. There was actually before the stream started, I was doing research on. No, I was thinking of asking Gemini something, but I forgot exactly what it was. So I can't write that. At some point later, I might remember it because I need to see something that kind of just triggers the memory, and I'm like, okay, yep, that's what it was. All of a sudden, I'll remember it. Maybe I might remember it off stream. Um, you know what? That being said, so we are done with this. I can read the bootloader technology thing off stream. For now, I think we can get into Nano. I have the Nano documentation here. There's going to be a bit of reading to do, just to get an understanding. I don't think I'm going to be editing any of the code. Oh, speaking of like nano and graphics, so I decided to, after yesterday's stream, I decided to somehow try to load a Firefox project in NeoVim, and just let the thing take how much ever memory it's taking. So I closed down a bunch of things, including the browser, to give the system enough memory, right? I just wanted to see how far the Rust analyzer was going to continue taking up memory. It went up to 6.1 GB. So just opening up an empty Firefox project in NeoVim was 6.1 GB, for the Rust analyzer, I mean. And that's wild because, dude, just having the project open is 6 GB in memory. The editor is not that heavy. The editor is like a couple hundred MB at max. But like just having the project open in NeoVim, the Rust analyzer is taking up so much memory. I have no idea how to like solve this issue. I'm gonna have to do some research. I did ask Gemini for solutions, for suggestions on what I could do to limit how much memory the Rust analyzer was taking. Um, but it turns out there's no direct solution for that, at least from what Gemini said. I still have to go and do like a proper Google search to see if any other, like, if any Rust community members have some. Oh, I just remembered that I've joined a Rust Discord, so I could probably ask the question there. Yeah, this just occurred to me. I should do that. I should do that. Yeah, I should do that. Maybe someone might have some information there. Well, that being said, I decided to go back to Nano, which is what I was gonna be doing anyways. Like that's what the plan was. And Nano also takes a couple of GB, but fortunately it stops at like between 2 and 2.5 GB. So at least that I can deal with. That's not nearly as bad as um, 5.7 GB with Bevy and 6.1 GB with Firefox and stuff like that. So yeah, we are going to be learning and using Bevy. Did I say Bevy? No, I mean Nano. And I have actually already written a bunch of the boilerplate code. I've written a bunch of the initial example code. Oh, what am I doing here, dude? What was I trying to do? I can't remember. Oh, yes. I was trying to check how much memory was being taken up. Okay, so if I do open up the Bevy project, I also just realized that once I load the once I show BTOP on screen, it's not going to make too much sense because it gets green screen. Anyways, yeah, if I load up Nano, if I load up a Nano project like this one, then it's going to take at least 2.5 GB. So let's open this up, let it do its loading thing. Oh God, there's the fans. There's the fans. Just a second. Yeah, there it is. So it's increasing, but fortunately, in this case, it's going to stop at a certain, it's not going to keep going. Oh, we are at 2.8 GB. My bad. I thought it was 2.5 GB. Okay, cool. So, um, anyways, we're not going to be like running the program. We're going to be reading this and understanding the various components involved here. I have run the thing. Just so you know, I like running this code. It brings up a window, a GUI window, and in that window there's a purple screen. Um, there's I think there's one function missing here because in this code, aside from the main function, in this code we have the model, update, and view functions. I believe there's an event function as well, or it's some other function. I can't remember what the name was. Maybe it was event. I think it was event. I don't remember exactly. Um, yeah, so there is one more function which we're probably going to get into it like later on once we go, because there's like a bunch of examples that we can go through here. Let me show you the list. They've got a bunch of community made tutorials. Shout out to all the people that made these tutorials. Shit, dude, I have no idea what I'm gonna do once Nano moves to Bevy. The the best I can hope for is that they don't move for another like 6 months or 1 year or something. Because I need Nano to remain its own thing. Actually, okay, this has me curious. Just a second. What if I wanted to do only 2D stuff? What if there was something that was really lightweight? Okay, I have to ask this question. Wait, we can how do I do this? Okay, I can open up Gemini here. Wait, let me yeah, I can open up Gemini here, and in the meantime we can do some reading. Actually, wait. Okay, it hasn't loaded yet. Right. So there's a couple of examples here for stuff. I need to remember because, dude, holy shit. Nano is like, such a useful thing for me right now. Oh God, I hit something. Okay. Uh, what was I doing? Yeah, okay. Something weird just happened. I have no idea what. Okay. Right. So before I forget, okay. So I've been meaning to get into creative coding um, through Rust for a while now. I found an amazing crate called Nannou. There were also a couple others like Berry and Fireox, which were aimed more towards game dev. I was planning on using Nano for cre- both both for both um, creative coding and game dev. I recently found out that Nano is gonna be moving towards becoming a Bevy plugin. The work is still in progress for that, so that's probably not gonna be for a while. The thing is, all three of those crates take up a good few GB in memory whenever whenever they are loaded by the Rust analyzer. So far, Nano seems to be the only one that my um, admittedly limited resources system can tolerate. What I'm wondering is what other similar crates do I have as choices for creative coding, or even just displaying graphics? I don't mind if they are purely, is that the word I should be using? No, mostly 2D either, but I'm just curious. Because I could look into, because I mean, Kiss 3D exists. That's a thing, right? I haven't looked into it, but like that's definitely a thing. In fact, I would love to explore both 2D and 3D to see what my options are. Okay, so let's see what options come up. You know what? There is also like the much more lower level option, which is WGPU, but like that's a huge headache. That's a that's a my assumption here would be that that would be kind of like um, learning DirectX, learning to use the DirectX API to do creative coding. Because like you'd be doing a whole lot more foundation before ever being able to do any creative coding on there. That's kind of like where the joke comes from with graphics programming. Like you write like 100 lines of code, and then finally you can display a triangle on the screen. And like it's a joke because like a lot of people understand, some people don't understand, which is why they take that joke way too seriously. But like a lot of people understand that it you're not writing 100 lines of code just to display that triangle. You're writing that 100 lines of code because that's the amount of setup that's required before you can start displaying stuff, before you can start doing graphics programming. So it's not just that triangle that you can display at that point. At that point, you can display an entire scene using that same setup. You don't have to rewrite that entire setup for every single triangle that you want to display, but you do have to create that setup before you can display anything. So yeah, I don't want to go down to the like I don't want to go down to like a really low level, which is kind of why, frameworks like Nano and Bevy and Fireox and all exist, and Kiss 3D, of course. There was okay, awesome Rust list. Somebody had made somebody had made a list with a bunch of very useful crates pertaining to various subjects. Okay, so there's one here. Actually, okay, they have a separate section for games and a separate section for graphics. They don't have something for creative coding, right? Let me just make sure that there's nothing for creative coding. Development tools, libraries. Okay, okay, wait a minute. Oh, I'm looking at applications. I'm supposed to be looking at libraries. Actually, I could open up this list here. Give me a second. Uh, awesome Rust list. Okay, so this is the list. Let me transition back here. Right, so this is the list. I guess we'll go through the list. I don't know how often they update this, but it's a pretty long list with a bunch of very good information. I'm also not expecting them to constantly, keep checking if crates and tools and stuff are still in development. So I appreciate the information that they are putting out there. Right. So this is for applications. I'm looking for libraries specifically. Okay. So now in libraries, under libraries, we have there's going to be graphics. There's going to be game development. Right. So let's open that up and let's open that up. Image processing, GUI, so and so, so and so, so and so. Okay. 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 I need to see what they have under reverse engineering. What Rust-based tools have they created? Like, I want to see if there's um, something that's like on par with, or aiming towards being like Radari or Cutter or Ghidra or what others do they have? Ghidra is like it's Java based. Radari and Cutter, I believe, are both C based. I think so. I don't remember. Okay. So for game development, they have a couple here. Awesome quads, a curated list of wait a minute. A curated list of links to mini quad and macro quad related resource. Yeah, macro quad was something somebody had I think Gemini had mentioned this. Oh, also, speaking of Gemini, let's take a look at the thing here. Let's see what the response was. Mini quad. Um, just a second. We don't seem to be scrolling. So let me just fix that. Okay. Of course, it's great that you are diving into creative coding with Rust. The ecosystem is indeed rich and can sometimes be overwhelming. Given your interest in Nano and your constraints with resource usage, you're right to explore other options. Here are several excellent crates for graphics and creative coding in Rust, categorized by their level of abstraction. Okay, high level creative coding and game frameworks. These are the most similar to Nano and Bevy, offering a complete application loop, windowing, and drawing abstractions. MacroQuad. This is probably the closest you'll get to a lightweight processing like experience in Rust. Focused on 2D games and visualizations, it's intentionally simple and easy to get started with. Why it might fit. It's known for its very fast compile times and low resource overhead. It's a great choice for game jams and quick creative coding sketches. The entire API is exposed in a way that's very beginner friendly. It can also compile to WASM out of the box. Then GG Easy. I remember looking at GG Easy. This is a lightweight 2D game framework. It provides a simple API for graphics, input, and audio. Why it might fit? It's designed to be simple and has been around for a while, so it's quite stable. It's less opinionated than a full game engine like Bevy, but it provides more structure than a raw graphics library. Then we have mid-level 2D, 3D graphics libraries like, okay, so these libraries give more direct control over the rendering pipeline without being as complex as raw GPU APIs. I'm surprised that WGPU is being mentioned in mid-level, though to be fair, WGPU is what helps you get to the lower level, but like WGPU gives you an abstraction layer, and then the actual low level would be the DirectX API, OpenGL, or Vulkan, or whatever others there are out there. Um, These are excellent for building custom engines or complex visualizations. Okay, this is a so WGPU. This is a library that powers both Bevy and Nano, and Firefox is moving to it. Focus, a modern cross-platform safe graphics API based on the Web GPU standard. It works on Vulkan, Metal, DirectX 12, and OpenGL. Why it might fit. If you want to learn the current way of doing graphics in Rust, this is it. While it's a lower level, while it's lower level than Nano, learning it directly gives you immense power and understanding. It's a library, not a framework, so Rust analyzer load is typically much lower, um, as it has fewer dependencies to parse. You'd be responsible for your own windowing and application loop. Then MiniQuad. This is the graphics rendering backend that MacroQuad is built on. It's a safe and cross-platform rendering library that provides a single unified graphics API on top of the OpenGL, GLES 2/3 and WebGL. Okay, why it might fit. If you like, um, if you like the simplicity of MacroQuad but want a bit more control, you can use MiniQuad directly. It handles the graphics device and shader compilation for you, but you manage the drawing logic. Then KISS 3D. Focus, a very simple 3D graphics engine for demos and prototypes. Why it might fit. Its primary goal is to get a 3D scene on the screen with minimal boilerplate. KISS 3D is. Hey Sarah, hello, hello. Welcome to the stream. How's it going? We are currently learning about we are looking into various graphics libraries that I can use in Rust, because I'm currently using Nano. I was planning on using Bevy or Firefox, but um, they both are a little too heavy to load. So I'm looking into more lightweight options. Um, right. KISS 3D is fantastic for minimal boilerplate. Okay. It's built on top of the N-algebra library for math and is great for quickly visualizing 3D algorithms or data. Immediate mode GUI/2D rendering. These libraries are primarily for building user interfaces, but have powerful 2D drawing capabilities that make them suitable for creative coding, especially for interactive tools like data visualization. I've never heard of this one. Piet provides a unified 2D drawing API. Just popping in. Well, I appreciate that, Sarah. Thank you. Thank you for popping in. Hell yeah. Um, I hope you're doing well. I hope things are well with you. Focus. Providing a unified 2D drawing API that can be implemented on various backends like Cairo, DirectX, etc. It's part of the Druid GUI toolkit. Why it might fit? Um, if you want to create 2D graphics that can be rendered in different contexts, like a GUI app, a saved SVG, or a web canvas, Piet is the tool for the job. I'm curious about macro quad now. Hold on, there was macro quad and one more. I'm definitely not going down to the WGPU level. Oh, GG easy. So let's take a look at both of these. Okay, macro quad, cross-platform game engine in Rust. This does seem to be currently being developed. I could look into this, definitely. Features. Same code for all supported platforms, no platform dependent defines required. Efficient 2D rendering with automatic geometry batching, minimal amount of dependencies, build after cargo clean, takes only 16 seconds on so and so. Okay. Immediate mode UI library included and single command deploy for both WASM and Android. Okay, MacroQuad is a simple and easy to use game library for Rust, heavily inspired by Raylib. Okay, all right, okay. We can check this out. We can MacroQuad examples folder. Let's see if they have MacroQuad examples folder. Okay, there's a PNG. I'm not sure how I'm supposed to be. Do they have a website that I can look at? Okay, there's macroquad.rs, articles, iOS. Nope, nope, that's not what I'm looking for. There's a Discord server. There's awesome quads. Okay, that's what was required. A curated list of links to macroquad slash miniquad related code and resources. So there's games built with macroquad. There's games built on top of miniquad. Then there's games built on top of good web game. Oh, GG Easy. That's another one that I'm supposed to look at. GG Easy. Oh, macroquad.rs is okay. I was assuming that because it was .rs, so it was going to be like documentation kind of thing, but no. They have a proper website. Let's take a look at examples. Dude, you know what? It's very simple graphics. Um, it's very simple graphics, but I'm guessing that's what you get with, you know, a lighter weight library. Or maybe it's just that the examples that are, or maybe, okay, maybe this is meant to be like super lightweight kind of thing. It's not meant to be really heavy. Oh, you know what? No, hold on. Just a second. I'm saying that it's really simple graphics, but those are probably just the examples that they have given. That doesn't mean that it doesn't look great, right? Because they have examples for 3D, they have something for screen texture. They also have shader toy here. Like someone has legit implemented shader toy. I'm assuming through MacroQuad. Yeah, I'm curious what the a book on how to develop a classic 2D game loop. No, a classic 2D shoot 'em up game in MacroQuad. Okay. Texture, Snake. Okay, there's a breakout game, there's asteroids. I think someone implemented Conway's Game of Life. Then there's a first person thing here as well, which tells me that 3D is supported, I'm guessing. Yeah, I'm curious about this. Yeah, no, I take it back. I don't know if it's like the examples that are given might look simple, but that doesn't mean that you can't make something nice looking with it. I do wonder about the performance of the stuff that you're making. Okay, so there's mini quad, there's macro quad, Rust RPG toolkit, Emerald game engine with physics, audio, graphics, and ECS. Was this the engine that I was looking at that wasn't in develop? Yeah, this is not in development anymore. This has been archived. Okay, I'm really curious about this. I'm curious about macro quad. So just a second. Oh, yeah, I could just ask the question to oh, wait, GG Easy. I was looking at GG, or I was supposed to look at GG Easy. Rust library to create a good game easily. And this seems to be currently in development. GG Easy is a Rust library to create a good game easily. More specifically, GG Easy is a lightweight cross-platform game framework for making 2D and 3D games with minimum friction. It aims to implement an API based on a Rustified version of the Love game framework. This means it contains basic and portable 2D drawing, in addition, 3D, which Love doesn't have an API for, sound, resource loading, and event handling. But finer details and performance characteristics may be different than Love. I should open this up. I should open this up here. So we have macro quad and we have wait, just a second. What did I open up here? I need to close a bunch of tabs before everything slows down. So we can close this, we can close that, and oh, actually we have the list here. So for game development, there's GG Easy, and macro quad is not listed here for some reason. It should be under awesome quads though. Oh, I saw Godot listed here and I was like, hold on. What do they mean Godot? But it's the Godot bindings. Okay, we have GG Easy here. We can open up the website as well. There's also macro quad. Just a second. Yeah, this is macro quad. Okay, right. So this is GG Easy. Let's take a look at some screenshots. There's an asteroid game. There's a text-based game. There's a tile-based game. Okay, okay. Oh, that's interesting. Um, yeah, yeah. So there's this. Actually, I should probably go to a different thing. Okay, let's take a look at examples. Examples goes to that. Yeah, okay, I'm curious about what these examples look like. Let's, because I was going to look at the API for, you know, understanding what the structure of the program is like. Okay, the simplest possible example that does something. Um, okay, GG easy. Oh, wait, no, that's a use statement. Right, so we have a state here, and then for the state we implement something. Then for the, then we implement, oh wait, we are implementing more stuff for the state. Okay, so there seems to be some amount of boilerplate code before we can do stuff, which is fine. Um, we'll just have to see how much of a headache that ends up being. Right, same thing here. Then we go into main. Main returns game result. Okay, so this is our draw function. Okay, okay. All right. Okay, so there's GG Easy, which I am gonna look into because I'm kind of interested in what extra features it's got compared to Macro Quad. But yeah, we should also take a look at Macro Quad. So this is Macro Quad. The website is not listed here, but this is their website. Um, where is it? This is the website, macroquad.rs. And this is where I saw the examples. These are the examples through macroquad. Now, the interesting thing is that, okay, this does also support 3D because it mentions first person here. So I'm curious about how they set up the 3D thing. So there's a link to the example. There's a GitHub link to the example. We're gonna go check that out. Oh, also here's the video. I hope there's no, you know what? Let me just mute this. Yeah, just in case. So I'm gonna click this. This is the video. Give it a second. The video is taking some time to load. Actually, is it taking time or is this meant to be an image? Because this first person thing loaded up well. Yeah, this is the first person thing. Oh, this is not a video. Dude, somehow that didn't occur to me. Yeah, somehow that didn't occur to me. We should close this because that means 3D here is an actual like demo. I need to know how to navigate this. I guess it's just displaying. But the fact that we can display 3D objects here. That tells me something. So, okay, you know what? I'm gonna ask this question to Gemini. Okay, so um, looking at macro, quad, and GGEZ, both seem pretty interesting, and both seem to have the ability to do 2D and 3D rendering. Um, Give me a rundown of both of the libraries to help me pick one. Also, perhaps maybe even compare them to Nano, because I've seen some crazy examples um, presented in Nano that I'm not really seeing with either of these, but I'm just wondering if that's just because people haven't done it yet. Or is it that Nano provides you with something extra that these don't? Now, I'm asking this question, but I have a feeling that the answer to that is that Nano provides a more higher level API, because Nano's thing is it's very simple, right? It's like a model view and update kind of thing, and then whatever you're doing, you do it within that, and people are able to do quite a lot within that. So I'm wondering what this. I haven't looked at macro quads examples. Yeah, I haven't looked at macro quads examples. Let's take a look at this basic shapes thing. Let's see what pops up here. Holy shit, dude! I didn't realize that what I was loading in the examples, it was actually those were like live examples. I thought I was looking at videos. Okay, this is super simple. Holy shit. That's crazy. Let's take a look at the 3D example. Um, we can also take a look at the camera example. Why does it say macro quad main camera? What does that mean exactly? I need to look into that. Like if we ever get into this. Um, okay, Gemini is responding. Okay, so we're gonna regenerate the response here. This tends to happen sometimes when I ask it to do comparisons or a rundown of like multiple different things. I still haven't fully understood how it gets into this loop. And it's like then it has to avoid this loop. So it has like a loop detection thing. So I don't fully understand that, but whatever. We can come back to this. These are our examples. We are currently here. We can close this. And this is our basic shapes thing. Okay. There was a 3D thing as well. That's this. Okay. So load texture, load texture. Okay. Draw grid. Wait, going 3D. Set camera. Okay, that's interesting. So what the camera sees depends on what kind of camera you set up. Oh God, what's going on here? Holy shit, chill out, chill out. You're freaking out, dude. I don't know if you guys can see Gemini like freaking out on my. Okay, yeah, you can. Is it done? I'm just gonna let it. Yeah, whatever. It's fine. Okay, excellent question. This gets to the heart of the philosophy behind behind these libraries. You're right that all three of these all three can get pixels on the screen, but their approaches and built-in toolkits are aimed at very different kinds of tasks. Let's break it down. Macro Quad, the quick and easy sketchpad. Get something running fast. Macro Quad is heavily inspired by Raylib and aims to be the zero setup graphics library for Rust. It prioritizes simplicity, fast compile times, and oh, speaking of fast compile times, I would need to see how heavy GGEZ ends up being. But okay, fast compile. Actually, no, GGEZ, they were explicitly mentioning that they are super lightweight, right? Yeah, I need to check that. Well, I need to check the repo and see if they were mentioning that, and then I also need to see how well or bad, I guess, it performs on my systems. Okay, fast compile times and a very flat, easy to discover API. Rundown, API style. Simple, immediate mode style drawing. You call functions like draw circle, draw texture, etc. every frame. Structure, minimal. You provide a single async function that contains your while loop. It's very freeform. 2D versus 3D. Primarily a 2D library. It has basic 3D functionality. Wait, primarily a 2D library. It has basic 3D functionality. You can draw cubes, spheres, and meshes with a simple camera, but it's not its focus. It's great for 2D games, data visualizations, and simple 3D scenes without complex lighting or shaders. Okay, okay, that's good to keep in mind. Strengths: incredibly easy to start, compiles very quickly, cross platform, including WASM and WASM for web builds, is a primary feature. Then GGEasy, the lightweight 2D game framework. Philosophy: provide a solid, simple structure for making 2D games. Uh, GGEasy is inspired by the Love framework for Lua. It gives more structure than MacroQuad, but is far less complex than a full engine like Bevy. Rundown: API style. Retain mode ish. You typically create mesh objects um, from your geometry and draw them each frame. You interact with a context object that holds the graphics and event state. Structure more formal. You implement the event handler trait, which has update and draw methods. This cleanly separates your game logic from your rendering logic. 2D versus 3D. It's a pure 2D library. It has no built-in 3D capabilities. It focuses on doing 2D very well with hardware accelerated rendering with WGPU. Strengths. The enforced structure is great for keeping projects organized. It has a mature API and is very stable. Excellent for building polished 2D games. All right. Then, Nano. Nano difference, a creative coding. Oh, you know what? The first massive difference here is right off the bat, Nano is not, um, it's not a game development framework. It's a creative coding framework. Whereas MacroQuad and GGEZ are more focused on games. Games and, well, visualizations, but it seems like they're more focused on games. Do the websites also say the same thing, or is it Gemini saying that they are focused on games? Let me just. Okay, GGEZ is good games easily, so it's already aiming at games. Um, then MacroQuad, yeah, simple and easy to use game library for the Rust programming language. Okay, Um, right. A creative coding powerhouse. This is the answer to your core question. Hold on. I just remembered this. Um when we were doing research, I think because of the research, we had kind of figured out that okay, Nano has both Lion and Noise RS support. Yeah, yeah. I remember something along those lines. And again, I guess right off the bat, the major difference between these two is one is a creative coding library and the other is a game engine. The other is the other two are great if you want to actually make games, but if you just want to do creative coding, then Nano is much better. I kind of want to do both, and I don't want to have to learn two libraries. Okay, hold on. This is the answer to your core question. The quote unquote crazy examples you see from Nano are possible because Nano is a full fledged creative coding framework, not just a drawing library. It comes with high level abstractions specifically for generative art and interactive installations. Nano gives you extra things that MacroQuad and GGEZ do not. A rich geometry pipeline. Nano's drawing API is built on top of Lion, a powerful vector graphics tessellator. This makes it incredibly easy to create, manipulate, and render complex 2D shapes, paths, and polygons with GPU acceleration. Doing this from scratch in other libraries is a significant amount of work. Deep GPU integration, I think that's because of WGPU. Nano is designed to give artists easy access to the GPU. It has first class support for writing your own shaders and hot loading them. Using compute shaders for massive parallel computations. I didn't even know that. Um, and advanced texture frame buffer management for feedback loops and other effects. Batteries included for artists. It comes with a huge suite of tools that creative coders need every day. Noise generation, color science, randomness, physical device I/O, first class support for OSC, MIDI, and audio streams, which is essential for creating interactive art installations that respond to music, controllers, or other applications. Application and windowing model. Nano has a sophisticated app model that supports multi window applications, GUI integration, and a highly flexible application loop designed for creative work. Dude, I wonder if oh, you know what? Hold on. So I'm gonna ask this question again. Even though after looking at all of these, it kind of seems like I still want to stick with Nano, because it seems like if I did decide to do a bit of game development, I would have to, do a bit of a setup within Nano, but it's not like it's impossible, right? Nano is meant for creative coding, and game development can definitely come under creative coding. It's just that it needs to be a little more structured and a little more organized and stuff like that, right? You would have to build systems. Um, Stick with Nano or plan to return to it. There you go. I was about to ask this question. Your goal is to create the kind of complex generative and interactive art you've seen in its examples. The cost of its resource usage pays for a vast toolkit of powerful high level abstractions that let you focus on the art rather than the low level implementation. Choose MacroQuad if you want to get started right now with minimal learning curve. Your focus is on simple 2D games or visualizations, and you value fast compile times and low resource use above all else. Choose GG Easy if you want to build a slightly more complex 2D game and appreciate a clean, well organized structure that separates logic from rendering. And stick with Nano if you want to do this. Okay, here's my thing. I plan on doing both creative coding and game dev, but I don't have so much time. The answer here is going to be Nano, but I want to see if Gemini can give me like some extra information that I can benefit from here. But I don't have time to be learning multiple frameworks. Nano does seem a lot more appealing, even if it causes the Rust analyzer to take up close to 3 GB of memory. Memory during coding. Yeah. Okay. I think I'm sticking with Nano. Okay, so let me go back to this and close a bunch of the other stuff. Close this and this and this and this and this and this and this. Wait, can you guys actually see the menu? I don't think you can see the menu. Probably not. Okay. Yeah, dude. Okay. Now, while Gemini is responding, give me a second here. Okay, we should probably close this because I think this is taking up a bunch of memory. Though, I mean, it's not that bad that it would start to lag, but okay, whatever. Okay, Gemini responded. I understand completely. It's a classic dilemma, balancing powerful features with resource constraints and the desire to specialize in one tool. Given your goal of doing both creative coding and game dev without learning multiple frameworks, and your stated appeal towards Nano despite the Rust Analyzer memory usage, I lean towards supporting your. Oh, what just happened? Why did the Unity Hub just open up? Probably because I accidentally clicked on this thing. Yeah, never mind. Um, yeah, I lean towards supporting your inclination to stick with Nano. Here's why Nano might still be your best bet for a hybrid approach, along with strategies to manage Rust Analyzer's memory. Why Nano for both creative coding and game dev? Creative coding benefits directly aid game dev. Oh, creative coding benefits directly aid game dev. The advanced features Nano provides for generative art and interactive installations are incredibly powerful tools for game development as well. Complex visuals and effects. Nano's robust geometry pipeline and shader integration, including compute shaders, mean you can create stunning, unique visual effects, procedural environments, particle systems, and highly stylized game graphics that would be much harder to achieve in macro core. As I was reading this, it just occurred to me. I kept on thinking about like Rapier integration into Nano, but not every game requires collision detection. Not every game is possibly even going to require physics. Like, what if what I made didn't require either of those things, like, at all? Yeah, okay. Continuing reading. Um, Much harder to achieve. You can, wait, mean you can create stunning, unique visual effects, procedural environments, particle systems, and highly stylized game graphics that would be much harder to achieve in MacroQuad or GGEZ without significant custom work. This is where those crazy examples come into play for games too. Procedural content generation. For open worlds, unique levels or randomized elements, Nano's tools for noise generation, tessellation, and GPU compute are invaluable. I need to look into the GPU compute thing as well. Yeah, I need to look into this. I'm also wondering if, like, whenever Nano does move towards becoming a Bevy plugin, is it possible for somebody to make like a fork? Maybe I might make a fork and just hold on to that version just so I can use that specific version for as long as possible. Or, or fingers crossed, in within the next couple of months, or maybe sometime in the next year, whenever it happens, I might get a better machine that I can do, you know, coding on. Well, specifically Bevy coding on. Actually, it's probably still going to be Nano coding, but like because Nano is going to be running on Bevy, so then now there's going to be that added load. So yeah, maybe I might get a good enough system. Anyways, um, interactive experiences. It's strong support for OSC MIDI and audio input output is not just for art installations. It can be used for unique game control schemes. That's what, dude, now that it's being mentioned this way, this is what, as I was reading it, I was like, holy shit. Considering that it's a creative coding framework and it has a bunch of these extra things as well, there's so much extra that you could do with this. There's so much that you could do with this. That's crazy. Okay, okay. Music reactive gameplay or innovative user interfaces. Okay. Experimental game design. If you're looking to push boundaries beyond traditional game loops, Nano's flexibility gives you the freedom to build highly experimental and artistic games. Then, building blocks, not opinions. While not a game engine in the Bevy or Fireox sense, Nano gives you powerful building blocks. You'll have to implement more of the game logic yourself, like physics, state machines, collision detection, um, but you have ultimate control over how it's done. This can be a pro or con depending on your preference. Addressing the Rust analyzer memory usage. The 3 GB so-and-so is indeed substantial. Here are several strategies you can employ to mitigate this, especially within VS Code. I'm not using VS Code, but yeah, all of these things that are being suggested, these were suggested in another conversation that I had with Gemini as well. Um, the crazy thing is, these things, I feel like they will take away a bunch of the features that I currently have, that I'm currently benefiting from in other projects. They'll take away those features, but then I don't know. I'm not gonna get, how do I say this? It'll take away those features just so I can save memory for this one specific instance because this is a very heavy library. Wait, consider Rust analyzer dot server dot so and so, though this is less commonly used and might require experimentation. This was not mentioned. I should look into this. While while Rust analyzer tries to be smart, you can give it hints or explicit limits. This was not mentioned before. Um, RA server memory limit. Right. Okay. So I'm gonna look further into this. Upgrade hardware if possible. Yeah, this is the most straightforward, but often least feasible solution. More RAM directly alleviates this issue. Obviously. Okay. All right. Great. So give me a second here. Um, just gonna close this so I can stop this and perhaps also close this. All right. Now, just a second. Give me a minute. Give me a minute. Okay. I just found something. I guess I didn't find something. Hmm. Give me just a second. Okay, you know what? I don't know who this person is and what they are doing, but they are creating some kind of time lapse. So we're gonna go check out this person's stream. We're gonna go hang out in their stream. Um, so that's gonna be it for today's stream. Um, yeah, I think I'm sticking with Nano. I'm gonna stick with Nano, and hopefully in the next stream we're gonna be doing a bit more Nano. I'm probably gonna continue learning about Nano, like even after the stream finishes, just so I can get up and running with very basic examples and stuff, and start practicing Nano. And yeah, dude. Um, I'm once again I'm excited for the streak that we have going with streaming. I haven't taken a whole lot of days off here, so I'm excited about that. Tic Tac, thank you for the follow, and Sarah, thanks for stopping by and hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.